figure on quizzes I give you more. Says you add silver ion slowly, so that you slowly build up the concentration of the silver ion in the solution until you exceed the KSP. That was the first problem on the quiz I gave you back. Essentially, it's the reverse of that. You know what the anion is, and you want to calculate the silver ion concentration to precipitate that particular anion. And I jotted down the numbers somewhere, so I have them. All I do is find them. Oh, I know what we found over there, giving KSP for the chloride. And by the way, a lot of this is bookkeeping because you have a lot of different numbers floating around once you start solving the problems. This was 1.8 times 10 to the minus 10. The KSP for the chromate, 1.1 times 10 to the minus 12. We solve for the silver ion concentration. You need it to just begin precipitating each one of these. Over to this one we got. This was the easy one because it was. And this one we had to do the square root. And you get 3.31 times 10 to the minus 6. Well, all these are molar, of course. So this is a much higher silver ion concentration than this, so the conclusion is silver ion precipitates first. Not silver ion, but it's said over there, silver chloride precipitates first. That's what we did over there, and then the next question is, and I only do it for a two-component system. I can do it for multiple components. In other words, we have copper, cadmium, all of those things. Which one precipitates first in the sulfide, which one second. But for the problems that I give you, I only ask you to compare two different things. So what is the concentration of the first ion to form precipitate? This is a tricky sentence. When the second ion just begins to form precipitate. As I said, what happens is, as you're adding silver ion, and I wrote the equilibrium problems over there, starts out at a low number. As that goes up, the chloride ion goes down. Eventually, when the silver ion gets up to this number, the larger number, you start precipitating silver chromate. So we already know which is the first one. It's the chloride ion. And what we're trying to do is find out what the chromate ion is. And we have to use KSP for silver chromate. This is where people start, because you see all these numbers, they start doing all sorts of strange things. So it's going to be the bookkeeping thing, 1.1 times 10 to the minus 12 over square. And the silver ion that you want to plug in here is the larger number. Okay? And one of the things you find, if you put the wrong number and you come back with the number you started with, and then you say, darn, that doesn't make sense. So that tells you to go back and look at this. So it's course, you have to square it because of the equilibrium expression for silver chromate. And that gives you, and I asked for the wrong thing, that's what I want, is let me do the problem over again. I did it wrong. I told you it's a tricky problem. In other words, we want to know what the chloride ion concentration is. Because we started precipitating chloride and it gets smaller and smaller because the silver is going up. So what we're going to say is the concentration of chloride ion. We want to start with KSP for silver chloride, not chromate. And in there we want to put the silver ion concentration that it increases to. And we get 5.43 times 10 to the minus 5. So you can see that the chloride ion went from 0.1 down to this number. So we've got most of the precipitate out. The question is, what is the percent remaining in solution? That's another question I can ask. There's a different question. There's something you still have to calculate that number. And that's how much is in there. And you're dividing by the original concentration here. It's a little confusing because both of them were 0.1, but this was the original chloride. That's the original chloride, because I will be mixing up numbers in the problem. So it says 5.43%. Oops, that's not what it says. I looked at the numbers and I got tired of doing it. It says 5.43 times 10 to the minus 2%. In other words, I knew it had to be 5.43, so that's the point, right? Or 0.05%. Now, I'm not going to ask you the question, is this a quantitative separation? Because some books are going to say quantitative means less than 0.1%. Other books are going to say less than 0.01. Notice, that is less than 0.1, so it would be quantitative in that book. But another book that said less than 0.01%, that would not be quantitative. So that's a subjective thing. It depends on the textbooks. There's no special definition of what quantitative means. But it still means you have to calculate this percentage that remains. Now this is that means 99.9457% precipitates. I don't usually ask you what percent precipitates because sometimes this comes out to be a really small number and I'd have to count 10 or 12 nines to see whether you did it correct. But in other words, the amount that remains plus the amount that forms precipitate has to add up to what? 100%. So that's the selective precipitation problem as opposed to different mixtures of ions that are precipitated by the same precipitating reagent. Questions about that? And there are several in the book, and I have several on the practice page. There are no